Welcome back guys, more examples with Expeditor. In the previous video we're looking at uses of dimensions, and we say that we use dimension analysis to test whether a given equation is consistent. So let's look at an example here. We take a scenario where maybe the velocity v of sound produced in a string is given by the expression v is equal to root TL over m, where T is tension in the string, m is the mass, and the L is the length of the string. So the question goes, show that the equation is dimensionally consistent. Show that the equation is dimensionally consistent. So that is our question. They're saying that the velocity of sound produced in a string is given by the expression. This is a V more clearly and precisely. Let me write it properly. V is equal to root TL over M. Show that the equation is dimensionally consistent. Of course, we said that for dimensional consistence, the dimensions on the right hand side should be equal to the dimensions on the right hand side. So let's look at our dimensions on the left hand side. Dimensions on the left hand side, we have V. So what are the dimensions of V? We know that the dimensions of V are L per T. Good. So the next thing here is looking at the dimensions of on the left hand side, brother. The dimensions on the left hand side are equal to the dimensions of that whole expression under root. But what we have under the root, we have tension. Tension is a force. So what are the dimensions of tension? Let's look at dimensions of tension. Dimensions of tension. Tension is a force. So the dimensions of tension are equal to the dimensions of the force, which we earlier got as ml per t squared. So let's substitute in this expression here. And remember, when you have anything under root, that is the same as power half. But let's first keep everything under root. So under root, we have the dimensions of tension, which is ml per t squared times L, which is the dimension of length divided by mass. Now you realize that this is the M and this is M, so they cancel, but please in your work don't cancel. I'm trying to show you what happens. And so in the next step, it means now we are having L times L. This is L squared per T squared. But this is under the square. So to remove the square root of L squared is L, and the one of that is -1. Therefore, we realize, or we see, that it is true. The dimensions on the right hand side are equal to the dimensions on the left hand side, and therefore we are good to conclude that the equation is dimensionally consistent. Now we're going to say that since the dimensions, and please when you're answering, don't use short form. Okay? Don't use short form. You say since the dimensions of the left-hand side in words are equal to the dimensions on the right-hand side, comma, then the equation or the expression is dimensionally consistent. That means that the expression is dimensionally consistent. So we've used dimension analysis to show that this expression of ours is dimensionally consistent. This is what we've said. And of course, one more example. Assuming this was example 1, let's look at example 2. And we see what example 2 has to do. But before that, again, I repeat for you, for us to be in position to show that a given equation is consistent, then we must first show that the dimensions on the different sides are equal to the dimensions on either sides of the expression. And then don't forget the principle of homogeneity. We said the principle of homogeneity said we only add like to like and subtract like from like. So that should be in mind always. So let's look at example 2. So example 2 says that the velocity v of a wave of wavelength lambda on a liquid of surface tension gamma depends more precisely, we say that the velocity v of a wave of wavelength lambda on a liquid of surface tension gamma depends on the density of the liquid, and is given by the expression below. It's given by the expression below. So the expression is that v squared is equal to gamma g out of 2 pi plus 2 pi gamma out of lambda rho. So the question says, show that the expression is dimensionally consistent. Show that the expression is dimensionally consistent. Now, you look at such a scenario. We have 3 quantities in this whole expression. We have quantity V, we have this quantity, and that. Now, I told you that from the principle of homogeneity, we only add like to like. So this implies that the dimensions of this bracket, should be the same as the dimensions of that bracket. And if that expression is consistent, then the dimensions of A of this should be equal to the dimensions